Want me to go over it, or do you guys got it down? Okay, you got that one down? Okay. Now, okay, so we're having the test Friday. Today we're going to review. The most important thing we can know how to do is this worksheet I gave you guys last time, right? How to write an explicit and a recursive formula. That's probably, and then rate of change is probably the second most important thing to know how to do. So, writing explicit and recursive formulas for linear, quadratic, and exponential, and then also the rate of change. That's going to be the next most important thing. Then we'll take the test. Okay, and I'll review some other stuff that's going to be on the test as well. So, okay, let's do this. I want a couple of you guys. I'm going to do it by volunteer right now. Would anybody like to volunteer to do problem number 2, an explicit formula? Problem number 2, an explicit formula. Okay, Jackson. Give me your first name again. Christine. Okay. Huh? Justine. I was going to call her Jerica, but Justine. Okay, come up and do this one. Number 2, explicit. Guys, number 2, explicit. What do you guys think? Is that right? What was the difference between terms on number 2? The difference was 3. Thus, 3x, right? Were the numbers going up or were they going down? Okay, so name the first 3 numbers of that one. 4, 7, 10. So they're going up by 3. So 3x. But if we put 1 in right here, 3 times 1 is 3, but we want it to be 4, so we had to plus 1. Raise your hand if you understand that. Okay. All right, we're going to go on to a recursive formula. Okay. Kelvin's going to do a recursive formula. All right. Kelvin wrote a sub n equals a sub n minus 1 plus 3. Now, all you have to remember on a linear, this is really fun. This is really easy. I want all eyes right here. Guys, all eyes got to be right here. Stop what you're doing. On a recursive formula for a linear, all you have to do is have a sub n equals the previous term. And we always do the previous term as a sub n minus 1, right? And then whatever the common difference is, it's add 3. So you do that, and that's it. That's how easy a recursive formula is for linear. Can you guys do that? Now, I got to show you a different notation. I got to show you function notation because 3 of us teachers are writing this test together and sharing it, and they've been using function notation. So I want to make sure, in case that's what we decide to do on the test, that we use function notation. So if I'm going to use f of n, how would I express my previous term? F of what? N minus 1 would refer to my previous term. And so if I was using that kind of notation, that's the notation for a recursive formula if I did function notation. This is called sequence notation. Okay? Yes? That way? Well, the problem is they've been teaching that way, and you guys are honor students, and there's kids that aren't, so they're telling me I need to do it this way because you guys can learn it faster. Hey, think about it. You guys... No, you guys can make the adjustment faster is what I'm saying. Okay? Justine. Yeah, if you guys want to write it. Hey, look, you guys, the question Justine's asking is, can you write it this way on the test? Yeah, because I'm correcting it. So I know what you're talking about. Okay? So, but if they give one, we haven't finished the test yet. We wrote it, but we got to change a bunch of things. But we've got to change that. Say that again. So there's a couple of matching problems. There's most of it's not. I don't think there's any multiple choice. Okay, most of it is you have to figure it out. Okay. Okay, next problem. Okay, I want someone to do on the quadratics. I want someone to do the explicit formula for number 2. Who would like to do the explicit formula number 2? Okay, go ahead. Kyle, right? Okay, Kyle's going to do the explicit formula for number 2 quadratics. Oh, wait, there was our answer for that one. I thought I turned this back on. I got to turn this back on. Okay, we know that that's going to be 2n because the second set of differences is 2. How did you get the minus 1? Tell us that, Christian. That's not a good enough answer. That's an answer, but I need an explanation. If I want number 2, you guys, right? If I put 2 in there, a sub 2. So we get a sub 1 because 2 minus 1 is 1, right? Plus 2n minus 1. 2 times 2 minus 1. Is that going to work? Okay, well, a sub 1 was negative 8. So to get a sub 2, you're going to get negative 8 plus 2 times 2 is 4 minus 1. 8 plus 4 is 12 minus 1 is, or negative 8 plus 4 is negative 4 minus 1 is negative 5. Did that give me the next term? Yeah. Okay. Let's do 4 on quadratics. Okay. Anybody get number 4 on quadratics and wants to show us? Okay, Alex. Let's do anybody want to do the recursive on that one? Or should I let Alex do both? Okay, Alex is going to do here's the explicit, right? This is number 4 on quadratics. Okay. Anybody get that? Now, some of you guys got that? Okay. Let's look at the table. Okay, on number 4, we get 2, 8, 18, 32, and 50. Did you match 1 up to 2 and 2 up to 8 and 3 up to 18 when you did this? Or did you start somewhere else? Well, let's try it. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. That's right. 3 squared is 9 times 2 is 18, right? Yeah. Hey, yeah, if you guys halved each one of these, that's 1, 4, 9, 16, 25. What do you guys know about all these numbers right here? What do you see? If you times them by their self, you get these numbers by timesing a number by itself, right? 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. And then you're saying what? And if you times those by 2, you get those numbers, right? So he knew it was going to be 2x squared. Does that make sense? Okay. So, got that. Huh? Well, we took half of all these numbers. Half of 2 is 1, half of 8 is 4, half of 18 is 9. If you take half of all those numbers, you notice these are perfect squares. 1 times 1, 2 times 2, 3 times 3, 4 times 4, and 5 times 5. Does that make sense? And then, so we know if we double those, we get back to these numbers right here. So we know it's going to be a number times it by itself, and then times by 2, right? So 2x squared is the explicit function. Okay, now the recursive. Alex, do you want to explain how you got the recursive? Okay. You guys will notice that what's the second set of differences here? 4. You guys, all eyes right here again. Stop what you're doing. All eyes right here. This is probably the hardest part, is the quadratic formula recursive part, right? Okay. The second set of differences is 4, right? So in my recursive formula, you get the previous term plus 4n. Whatever that difference is, it's always going to be that difference times n, right? And then if we're finding, if n is 2, because if we're looking for a sub 2, that's going to be a sub 1 plus 4 times 2 minus 2, right? Well, so let's say we didn't know what that was yet. We're going to go 4 times 2 is 8, and we know the previous term was 2. So that's 10. but we want it to be 8, right? So we got a minus 2. And that's how we know that. So you guys, if you always go to term 2 to find out what you got to add or subtract, if you always go to term 2, put it in here, a sub 2, which is equal to a sub 1, the previous term, which in this case was the value was 2, plus 4 times 2, because our common difference times whatever n is, which is going to be 2. And if you add these two numbers together, all you have to do is see what it is and add or subtract a number to get that second number right there. Okay, so that's how you get a recursive formula for a quadratic. That's probably the hardest formula to get, isn't it? You guys think or not? The hardest one that I mess up on? Actually, Mr. Prince made this paper. That's why he knew where the mistakes were the other day when he came in here. Okay? But I make mistakes too when I type stuff up, so. But I'm going to throw Coach Prince under the bus since he's not here, so. All right. Okay, who would like to do number 2 on the exponential? Explicit. I need a new person. I need Chaden. You want to do number 2 on exponential? Okay. Chaden's going to do number 2. Let's have David. Explicit. I want you to do a recursive for number 2 on the exponential when he's done. Thank you, Chaden. Hey, what is the key to you guys? What is the key to exponential functions? Find the explicit. Yeah, whatever the ratio that it's going up by, that's the base, right? Yeah, it's timesing by the previous number. Okay. All right, David, go put the. Do you have the recursive for that one? Okay. Recursive formulas are actually pretty easy for exponential, aren't they? Okay, now, David got it right, but I want to talk about how to write this. Everybody watch this, because in mathematics, sometimes the way you write things makes a difference. Yeah, I think it would be better to write the 3 times a sub n minus 1 like this. That would be a better way to write it. David was right. It's just that is the best. This right here is the best way to write it. Okay, when you're multiplying. Okay, any questions? Were there any other hard ones you guys want me to do? Look at. 3 on the exponential? Okay. Hey, did anybody get 3 on the exponential? You got it? You want to come write it? Okay, come write the explicit. Hey. Huh? Huh? Okay. Wait. Now, is that an exponential equation? Think about what you're writing. You're meaning to write something somewhere else, I know.
Oh, it's not right there.
Yeah.
Right?
Hey, you guys, that is a common error. Thank you, Phelan. Okay. Common error is to write the x down here. That's why I always try to get you guys to say 3 to the x, because sometimes you guys get a little lazy, and you say 3x, and you meant 3 to the x, and so you write it as 3x. Okay, so make sure you got it right there. Now, how did we know it was plus 2? Well, guys, if you take off the plus 2, isn't that the same as equation as last time? Look at those numbers. Aren't they all just 2 more than the one previous to it? 5 is 2 more than 3. 11 is 2 more than 9. 29 is 2 more than 27, right? 83 is 2 more than 81. Remember, that third number over is not supposed to be 27. It's supposed to be 29. Okay, any questions there? So what would be the recursive for this one, you guys? Go ahead, Alex. And then minus 4? Okay. So the recursive is f of n equals n equals 3 times what? F of n minus 1, right? Minus 4, how did you get that? Okay, so you take the previous term and times it by 3. So if I take 5 times it by 3, I get 15. I would have to minus 4 to get 11, wouldn't I? Okay, if I take 11, 3 times 11 is 33. I have to minus 4 to get 29. 3 times 29 is 87. I'd have to minus 4 to get 83. That is right. Good job. Okay. 3 times 83 is 249. Minus 4 is 245. I'm good at my times tables. All right. Alex, don't tell everybody my secret. Okay. You guys got this down, right? Okay, we're writing an expression for area of this rectangle and an expression for perimeter of this rectangle.